Hey guys, so now that we've looked at what sine, cosine, and tangent are, let's look at a triangle and find the sine, cosine, and tangent of a triangle. If you remember from the previous video, a really helpful acronym is this acronym called SOHCAHTOA. And all this acronym really helps us do is it helps us figure out for sine, cosine, and tangent, what are the ratios. And for sine, we see it's opposite to hypotenuse. So let's write our ratio as that, opposite over hypotenuse. And for cosine, it's adjacent over hypotenuse, adjacent over hypotenuse. And then lastly, for tangent, it's opposite over adjacent. And remember, when I'm saying opposite, I'm referring to opposite of theta. So opposite is going to be the side directly across from it. So that means 4 is going to be my opposite. And when I refer to adjacent in cosine, I'm referring to the side that is adjacent to theta. And so 3 is going to be the adjacent in this situation. And lastly, hypotenuse, when I'm referring to that, I'm talking about the side that is across from the 90-degree angle. In other words, the longest side of a right triangle. So let's go ahead and make sure we color code all of these the same way. And let's find our answers. So if sine is opposite over hypotenuse, we just simply look at what the opposite is. Well, that's 4 over the hypotenuse, which is 5. And so a lot of times you can write your answer as sine of theta is equal to 4 over 5. If your homework wants you to leave it in that form, that's fine. Or you can write it as 0.8. Because when you plug in 4 divided by 5, that's 80%. So it's 0.8. So essentially what we're saying is the ratio of the opposite side to the hypotenuse is 80% of the hypotenuse. And that's essentially what we're saying here. And then for cosine of theta, it's the adjacent over the hypotenuse. So adjacent is 3. The hypotenuse is 5. So my cosine of theta can be written either as 3 over 5, or if you type that into a calculator, you get 0.6. Again, it doesn't matter which one. These are saying the same thing. Typically, you'll see homework ask for it in this way, but it depends on what you're working on. And again, in tangent of theta, over here we see that tangent is opposite over the adjacent. So my opposite is 4 over the adjacent, which is 3. So tangent is 4 over 3. Or, again, plugging that in, you get 1.3 repeating. And so this is what sine, cosine, and tangent are of this triangle. Now let's go ahead and look at one more example real quick. Here we have an example of a trig function question. What is cosine of C? Now, C is referring to the angle. So this angle here is what we are going to be looking at. Sometimes we've referred to it as theta. But in this case, it's just asking what is the cosine of angle C. If you remember, SOHCAHTOA is a really helpful acronym. And in this case, we're worried about cosine, so we're going to go to the c part of it. Cosine is the ratio of adjacent to hypotenuse. So over here, we're going to say, well, cosine of C is going to be equal to whatever my adjacent is over whatever my hypotenuse is. So if you know what your adjacent is next to the angle you're looking at. So adjacent is going to be 24. Sometimes people accidentally mark this side as the adjacent because it's next to the angle. But remember, across from the 90-degree angle is the hypotenuse. So the longest side of the right triangle is always going to be the hypotenuse. And in this case, we're not given the hypotenuse. So what can we do? Well, if this is a right triangle, I know that I can use the Pythagorean Theorem. And the Pythagorean Theorem says this. It says a squared plus b squared, and those are the two shorter legs of the triangle, is equal to c squared, which is the hypotenuse squared. And so I can go ahead and I can plug in my numbers. It doesn't really matter if I do 70 squared plus 24 squared, or it doesn't really matter if I do 24 squared plus 70 squared. As long as my a and b are representative of my two smallest sides, then I'll be fine. Oftentimes, that's the biggest mistake with Pythagorean Theorem is students will just always plug in their sides for a and b. Well, in this case, we are going to plug in a and b, but it's only because these two sides are my legs of my triangle. So 24 is going to go in for a first leg. Do I have the second leg? Yes, 70 is the second leg, so 70 goes in for b. And c is always whatever the hypotenuse is, but we don't know what the hypotenuse is. So we're just going to write it in as c squared, and now we can solve for it. So if you do 24 squared plus 70 squared, you get 5,476, and that's still equal to c squared. And now we have something squared is equal to a number, and how we undo that squared operation is by taking the square root of both sides. And so if I do this, c squared, the square root of that is just c, and then the square root of 5,476 just turns out to be 74. And so that means that now the hypotenuse is equal to 74 units long. And so we're going to write this in over here just so we keep this in mind. It's 74 long. And that means now I can find what my cosine is. Because cosine is adjacent over the hypotenuse. We weren't given it, but now we solve for it because we had two of the three sides. So we can say that the cosine of c is 24 over 74. And before you circle your answer, we realize that both of these are even, which means they both reduce. So I can reduce this down, if I divide the top and bottom by 2, to 12 over 37. And 12 and 37 do not have any more common factors, so I cannot reduce this any further, which means 12 over 37 is the cosine of c. And this is my answer.